In this problem, we have the 2018 AMC 10A problem 12. How many ordered pairs of real numbers xy satisfy the following system of equations? X plus 3y equals to 3, and the absolute value of x minus the absolute value of y equals to 1. This might seem like a complicated problem because we have nested absolute values, meaning that there are absolute values of two variables inside a larger absolute value. But we can do this by graphing the equations. The absolute value one looks challenging to graph, but we can start by graphing it in the first quadrant only. This is going to be easier because in the first quadrant, the inner absolute values can be ignored because we know that x and y in the first quadrant are going to be positive, so the absolute values will not affect the value. And then after we find the graph, we can simply reflect it due to the property of absolute value graphs into the other quadrants. And then the graph, after some plugging in values, will look like this. The first quadrant. So we can reflect it into the other three quadrants. So it will look like this. And then you can just plug in the first equation, x plus 3y equals to 3. So we have 3y equals to negative x plus 3, y equals to negative x over 3 plus 1. And now at this point, it's going to be 1. So it'll just have a slope of negative 1/3. And then, so it'll look like this. The intersection points, there's going to be one here, and one here. So we have 3 intersection points, which will mean there can be 3 possible xy. And that is how you solve this problem.